Now we're going to look at answering this question, when will a salt or ionic compound dissolve? Now we're going to look at two more vocab words, soluble and insoluble. A compound is soluble in water if it dissolves in water. So for example, sodium chloride is soluble in water, table salt, but silver chloride is not. If we put a chunk of silver chloride in water, it would just sit there. It does not break apart into its ions. This is what's known as insoluble. Now there's going to be always a tiny bit that is going to be dissolved, but it's absolutely insignificant. So we're going to simplify things by just saying it doesn't dissolve, even though in reality a little bit does. Predicting whether a compound will dissolve in water is really not that easy. So we have determined which ones dissolve and which ones don't by experimental methods. Now we're going to use this table to help us out, help us predict solubility. You do not need to memorize this table. This table will be given to you on quizzes and our test. So this is how we look at this, how we use the table. These are compounds that are generally going to be soluble in water over here. If there are exceptions, which means they're not soluble, they're listed over here. There's only one set of cations, and that is the first three alkali metals and ammonium. If a compound, an ionic compound, contains these cations, it is always soluble. There is no exception. If an ionic compound contains these anions, nitrate and acetate, it is always soluble. Now chloride, bromide, and iodide are usually soluble except when they are paired with silver, mercury, or lead 2. In those cases, they will form insoluble compounds. Sulfate is generally soluble except with calcium, strontium, barium, and lead 2. It forms insoluble compounds with these cations. Now let's look at some solubility rules for ions that are generally insoluble. And notice these are all cations. Hydroxides are generally insoluble unless they're with these three, which makes everything soluble. And then our top three, actually our middle three, alkaline earth, calcium, strontium, and barium, are slightly soluble. That means they dissolve a little bit, but really not very much. Sulfides are insoluble except for these, which make everything soluble, and then calcium, strontium, and barium. And carbonate and phosphate are insoluble except for our magic 4 cations that make everything soluble. So you're going to be expected to look at an ionic compound and be able to figure out whether it's soluble or not. So let's look at a systematic way to handle this. If the compound has lithium, sodium, potassium, or ammonium, our magic cations, it's going to be soluble, regardless of what the anion is. If the cation is not one of our 4 magic ones, then follow the rule for the anion. If a rule says the compounds are soluble, then the exceptions are insoluble. And if a rule says the compounds are mostly insoluble, then the exceptions are soluble. And note that our slightly soluble is basically for our purposes going to be insoluble. Okay, so refer to the table, pause the slide, and see if you can figure out the solubility of these 5 compounds, whether they'll be soluble or not in water. Okay, let's check your answers. Potassium hydroxide is soluble because the cation is one of our magic ones, potassium. Silver bromide is insoluble. Bromide is mostly soluble, but silver is an exception. Calcium chloride, soluble. Most compounds with chloride are soluble, and calcium is not an exception, so it's soluble. Lead nitrate, anything with nitrate is going to be soluble. Lead sulfate. Actually, lead, I should have correctly named this. This is lead 2 nitrate. The charge of lead is 2. And this is lead 2 sulfate. The charge of lead is 2. This is insoluble. Sulfates are generally soluble except with lead, so that's an exception. So insoluble, soluble, soluble, insoluble, soluble. Now this is going to help us in the next section where we're looking at what are known as precipitation reactions. These are reactions where we get a solid when we mix two aqueous solutions together. So here's an aqueous solution. It's colored, but we have an ionic compound that's completely dissolved. It's being added to another ionic compound that's completely dissolved. And when the two mix, they form an insoluble compound, a solid. And this occurs because the cations and anions are exchanging. So let's look at this reaction. Here we have potassium iodide reacting with lead 2 nitrate. When these two react, here's our potassium iodide, here's our lead 2 nitrate. Both are colorless solutions. As soon as they hit each other, they form this insoluble lead 2 iodide compound. And let's look at our reaction. Here we have AQ, 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 and then solid. And if we look back at our table, this of course we would expect to be soluble. It has potassium. This we expect to be soluble. It has nitrate. Soluble, both potassium and nitrate, but this is not soluble. Iodides typically are soluble except with lead, silver, or mercury. So this is going to be a solid. If it's not soluble, it's going to have an S. And I know that it's a little hard to remember. This S stands for solid, not soluble. So if it's not soluble, if it's insoluble, there's going to be S there. So let's look at the ionic level of what's happening. Here we have potassium iodide dissolved in water. Here's lead nitrate dissolved in water. Okay, when we add the two together, the iodide and the lead can come together. And as soon as the iodide and lead come together, they're going to form an insoluble compound. The potassium and the nitrate are still dissolved in solution, hanging out. But as soon as the lead finds the iodide, they're going to come together to form an insoluble compound. Now, if two solutions are poured together and nothing happens, that's what's known as no reaction. We have AQ on both sides of the arrow, meaning that no ions have combined together to form a solid. They're still completely surrounded by water molecules.